Hey y'all, I'm here. Yeah, online class. I have one.
Hi, everybody.
Hello.
Hi.
Let me show you where we were at the other day on this process. I think we're pretty close. I um, I was just messing around with it a little bit. It'll keep the temperature right around 100 degrees. I mean, it'll go up past 100, back down below 100, but we're staying between the 80 and 120 degree mark. So I think we're okay. I'm going to run it real quick and make sure that we're at least in the ballpark, and then where is that still? That's still on. That's why.
What did you say?
I was trying to figure out why the strobe light was staying on. Um,
Right now, the screen that we see is the YouTube studio.
oh, that's the wrong screen. How do you like me now?
There you go.
All right, I'm gonna run this thing and we'll see what it does. Right now our temperature is at 95. You should watch the temperature climb to red pilot light is flashing. So we should see the temperature climb to over 100 degrees once that soldering iron is up. Should kick off at 100 degrees and the fan should kick on. We'll see how high it climbs until the fan can cool it back off. Remember, our temperature time, or sensor read timer is every 10 seconds. Is that right?
Probably.
Seconds. Something just happened. Okay, the soldering iron just kicked off and the fan just kicked on. seconds anyway. Where did the temperature go? Now we're at 108. So it's working pretty fast. It's just probably just going to keep going back and forth like that, but that's okay. We're doing what we need to do. So it's jumping from like 95 to 105. We could play around with it a little more so it wasn't running so constant like that, but that's good enough for now. I wanted to get into the HMIs. Okay. So we're going to use this software called Simul Programming. Everybody knows what I mean when I say HMI.
Honestly, no.
Yeah, I don't either.
Does anybody know what HMI stands for?
Happy Midges Incorporated.
Yep.
Whoa,
Awesome.
whoa, whoa. Wait, are they
Human
hiring?
Machine interface.
Hmm?
Human machine interface.
Yep. It's the touch screen up here. So this type is made by Automation Direct, and it's, I don't remember the model. But all you're gonna do is basically go onto this graphics studio software. It's kind of like, you're probably all familiar with how to run these picture type software programs. There's some simple rules to follow, like you're creating objects, and what we're going to do is create objects and tie them to the inputs and outputs that we have in the PLC that we ran in RSLogix. So the goal here is to have, you can have different screens. We'll have one screen that does like stop, start, input type things, and we can have other screens that show the temperature in Celsius. We can have, whatever you have associated with those tags in our program is what we're going to do. So I'm going to need somebody to have the list of tags open so that as we design this together in class, you can tell me which tags are what. Does that make sense?
Yeah, it makes sense.
It's been a while since I've done this, so bear with me. Say we'll call this what is it? Temp control. Garage temp control. And we need to select the panel type. Now I do have to know what it is. I think it's a EA9T6CLR.
Have we used this program before?
What?
Have we used this program before?
Not with me.
Okay, I was just curious.
EA9T7CL.
Ooh, all right, I'm here.
Hello.
EA9T7.
Oh, we're in factory talk.
No, this is that Seymour software that, remember way back when you told me that we needed? Okay, good talk. A9T7CLR is the panel type. And if we were doing this in classes, what you probably each have one or be sharing one. So PLC protocol. I gotta figure out which one this is. Ethernet. Allen Bradley. tag based. Control compact logic. So compact logics is what we want. I think it's this one. Ethernet IP, so we're connected to it straight from the Ethernet cable. Tag based. Control logics, we're using compact logics, so I think that's what we need. I want to look at this real quick. Oh, PLC IP address. Anybody remember what that is? Of course you don't. I'll look. 10.13.3.234. Can anybody remember that? Good.
10.3.234.
10.13.
Oh, see? I already can't remember.
3.234. Port, CPI, blah, blah. I think this is okay. We're going to find out pretty soon. Make a new project. Okay. So here is our screen. Right now we're in screen 1. We can have multiple screens. What did I say screen 1? We were going to put some inputs. I need feedback, folks.
Some inputs, that we said.
Yeah. So what kind of inputs do we have?
We have a distance sensor and a temp sensor, right?
Yeah, but I mean like human inputs, like push buttons and stuff.
Okay, so we have the green. Or does the selector switch count?
Yeah.
Proc
Okay.
sensor also.
Right. So you've got 3 push buttons, selector switch, and a proc switch. Basically, screen 1 should be anything that we're going to use. Instead of me pressing those push buttons and putting my hand in the proc sensor, we're going to have buttons on the HMI. We're going to create our own. Make sense?
Yes.
Okay, so let's put some buttons in there. Push buttons, switches, step switches, tri-state switches, indicator buttons. It's kind of cool. Let's do that. Indicator button.
Yeah.
Okay, let's do default. Drag that thing over there. And now, and remember, wherever I put this thing on this grid is where it's going to show up on the panel. So there's all sorts of options here. We can have a name. So what are we going to name this one?
Attempt 1.
Well, we have our list of tags, right?
Yeah.
So which switch, which push button or proc switch, what selector switch? We probably shouldn't do the selector switch. We should probably do we're using the procs as like a stop button, right?
Yeah.
Okay.
So green normally open push button. Should start out with the stop, or should it start out with the start, or should we use the procs as a stop and start out with that?
We can use it as a stop and start out with that. And remember, we don't have to use this block. I mean, there's other options here. These are just indicator lights. kind of looks like our you know,
Yeah, yeah, right.
our green, yellow, and red buttons. Does it not?
Oh, it does.
So right now we're on.
We're supposed to be seeing something? 'Cause I'm just seeing your screen. Like, are you
Yeah.
sharing video with us?
No, we're looking at this radio button.
Okay. My bad. I didn't have it on shared content. I'm just sitting there
So
looking at it.
button 1. It looks like on the trainer it goes green, yellow, red. So maybe we'll just call button 1 green PB. Or you could call it whatever it's associated with its tag. It could be process start. What is the description, the tag description for the green push button on module 1?
Green normally open push button.
That's all it is? Okay.
So it says.
Okay, so green, normally open push button. You can label it. Green. Oh, that's the whole thing. General. Okay. PB panel. How about that? You see where it changes up here? This is like the
Yeah.
preview of what you're going to get. You can change the frame type. All these different options. Kind of cool. Let's do that. Language. 4. Just kidding. Position top. So this would be for the label that you put in there. PB panel. If I push bottom, it'll move down to the bottom. You can. I wish you guys had this in class so you could play around with. But for your group, when we in Electech 230, the trainer groups where you guys are creating your own process, you guys can take over and create your own HMI interface.
Okay, that's really cool. I'm excited for that.
Yeah, it's fun. You can change the text color of the label. Let's make that blue. Background color, let's make it white, light gray. Object color, what is that? Whoa. Number of buttons, 3. Tag assignment, set by word tag, set by discrete tags. All right, so here's where we got to start thinking about things. Let's see. So text button 1, when it's on, we want it to say, let's say closed. And when it's off, we want it to say you know what? I'm going to leave those. Tag setting. green. Let's make this like a dark green when it's off and a light green when it's on.
Okay. Yeah. Well, how close are those colors together?
So like this is what, and remember, this is only the top button right now that we're looking at. Top green will be this color when it's off, and when you push the button on the HMI, it'll look like that.
Okay, yeah, that's a good idea.
And
Yeah.
then we can do the same thing with both the other buttons.
Okay.
Off.
Just saying, usually they're two totally different colors. Like white and green or yellow and green. But that's okay.
Maybe in your world, not in mine. What
Well,
was
maybe
this?
you've never
Oh,
asked
yellow.
about colors.
We
You
need-
could have said that before, but I think you missed a chance.
No, I'm just adding something so I can hopefully get participation,
Yeah, I don't
I'm
think you
just-
get participation points for arguing.
I do. I do. I'm special.
Gotta make it work somehow.
That's right.
All right, I don't know if we're gonna be able to do it this way unless we made 3 separate buttons, because it's only letting me change the
Like when it's on.
like
color.
all the buttons are the same color. I don't know why. But that's okay. We don't need them to be just like the trainer. So let's say when they're off, what is it gonna look like? When they're on. Okay.
Okay.
All right. So here's what we need to do. Right now, we just opened this program with the Seymour software. It doesn't know what kind of tags we have on our PLC, so we need to tell it that. So what I'm going to do is go to RS Logix 5000, and I'm just going to go offline, and I'm going to download it, save as, and if I remember right, change the save as type to an XML file. And in the directory where this is, C RS Logix 5000 projects. Okay. Save. And what that's doing is saving all the tag info and assignment, everything we did to create this program in a file that the Seymour software can read. So now I'm going to go to tag name database, and it's going to pull this screen up. Now all these these are called system tags that are already there. They can be used, but they're not tied to anything in our program. You know what I mean? So we could have done this backwards and used these tags that they have in the system. But we're going to import what we have in our program, find that file, C RS Logix 5000 projects, and there it is, XML file. File path, yes, yes, device. We should name this or not. Allen Bradley, Ethernet IP, client tag base. Yep, that's right. I don't care. I don't care. Import all aliases and tags. Sure. Import. Import completed. Cool. So now what we're going to see is I only want to see this DEV001. That's what I just imported. So I'm going to unclick these two. And look what we have over here. This should look familiar, right?
Oh, wow.
What am I looking at here?
Tags.
Those are all of our DLC ones.
How'd you do that?
I just showed you how to do it. Goofball. There's our B3s. There's our timers, timer dones.
Wow.
What I want to know is,
So,
does it show our description? Probably not.
so can I ask you a question real quick, Zach?
Yeah, go ahead.
Okay. So on a serious note, are you? Hey, shh, I'm talking. That's one of the older HMIs, right, from Automation Direct.
I don't know about older.
Okay, because some of those that we had in there were older than Logix 5000, correct? Hey. So I guess what I'm trying to see is, will this new software go back to the old Automation Direct where you could tie Logix 5000 to it and use all these tags and such in the older HMI display?
So if you had, are you talking about like in the other lab, like your trainer?
Yeah.
17, and I think that is a little bit older, but yeah, I mean, when we set this up and we told it what the model of our panel was, I mean, they have all of their they have all different kinds of models of HMIs. They have all different kinds of, I mean, this is Automation Direct. The
Right.
HMI is. The software that we're looking at is specifically for Automation Direct. They sell that software. I don't know if it will speak to an Allen Bradley HMI.
Right. The ones we had were all Automation Direct also.
So if they had their way, we would be using Automation Direct PLCs, HMIs, all that stuff. But it can communicate in between manufacturers. So
good deal. I appreciate it. I didn't know how far it'd go back, but fairly good it looks like. All right.
Yeah.
I'm gonna mute again because this kid won't quiet down.
I think I mean, I don't have experience with every type of HMI and all the old ones and all the new ones with this software, but Automation Direct is pretty good about tech support too. So if you ever run into anything like, hey, this isn't communicating with the HMI that I have, maybe you need a software firmware upgrade, like it could be as simple as that, but it all works within each other. I think that's what you're asking. So here's all our tags. What I want to see here is local 1 data, local 2. What I'm not seeing is like the channels. It's okay. Maybe it will be there when we local 2 out. Okay. Anyway. Let me cancel and see where we were. Okay. So tag setting. Do I need to turn off the chat room? Pot smoking kids. Who's giggling?
I don't know what you're talking about.
I am.
All right.
Been getting freaking called out.
I just said hi to Aaron. I didn't those two. I'm not associated with those two.
So tag setting. What are we gonna use for this push button? Local 1 data.
Yeah, and if we're using the green one, it's channel 1.
Channel 1.
Yeah.
For the green normally open.
Data dot 1.
Why doesn't it just have it like in the other software?
And what's the? It says NO dot up top. Is that number 8?
Where are you seeing that? Oh,
Underneath tag name.
yeah, I see what you're talking about. I believe so.
Yeah, it's the 8th tag in order.
Options.
It's a really handy program.
Why is it not letting me find? Like I see local 1 input data, but I'm not seeing all of the.
So usually it should show you that though.
Yeah. Well, we need to know which tag is which.
Is it okay? So is this program always remote run? So if you hit the, because I see it says false on the side right there. So if you hit the green push button, would it like go true?
I don't know what retentive means. The attribute is read write. I don't think when you're designing this, because we're not even communicating with the HMI right now. You know, this program is only going to communicate with the HMI. It's not going to read the PLC. We uploaded all the tag values. Let me try something else here. Define a valid tag. That doesn't make any sense to me because we haven't defined the. I'm going to try one more thing. I'm going to do 1 button and tag name. Why is it not? Local 2. Something ain't right. Because I'm not, like, all I'm seeing is I'm not finding the right channels here. I'm gonna go back and see if I didn't save that right. XML file, save. I want to import. Why can I not see tag 2.1? Having issues. Don't understand why I'm not seeing the right tags.
Is it not importing the tag numbers correctly, or
It's
are you
it's
just
not
able to-
it's imported them, but like I'm only seeing like local one data, but I'm not seeing the right channel. Does that make sense?
Oh, so it's only showing like the like the whole string for
Yeah.
all the different.
So
Okay.
I'm gonna try something. I'm gonna call this address local one input data. What is the address of the procs?
Channel
Is it-
0.
.00
No, channel 1, data 0.
data 0.
Or module 1, my bad.
When I imported all these, it should have come like all of those individual channels should have. I don't think there's something I didn't do right, but I'm going to try to input it manually and see if it works. So I'm just going to leave all this stuff as default, even though it's not really going to make sense. I'm going to hit OK, define valid tag. I just did. I wonder if I have the wrong protocol. Is it tools export tags and logic comments? I'm not sure this is right.
Did you export it as the text file? Because if that's what you did, then it probably just put all of the local data as like the text that it is, but that CSV is probably has more to it than that.
Yeah, and I think you're right. It just, this doesn't seem right. I'm gonna try this, but I don't think this is right.
Okay. Because I don't know either.
I know. It just like there's a certain file type that you have to save it as. Yeah, the CSV is not right. Crap. This might be a waste of a class period, guys, until I can get this figured out. I wish I'd have done this beforehand. Thought I could just wing it. Pretty sure it's this L5X. Let me try this L5K. I didn't do something right. I'm going to start over. No, let me do this. Read from panel. Ethernet. Browse. Right now I'm just trying to 10.13.3.222. Okay. Oh, that's the panel. Okay.
Sorry.
That's beautiful.
What the heck was that?
I stretched.
Okay.
Okay, so this is the one that's in there, and I'm gonna just take a look at what I had in there before. I'm pretty sure, yeah, I was communicating with the compact logics. Tag name. So this is what it should look like.
Yeah, see, that's weird. Because it says you have, doesn't it say you have Boolean 3 on that, a bit on that start button? Sorry.
Yeah, so I'm wondering if I don't have to,
Wish I could upload this photo.
What photo?
One I just sent.
No. No, stop. She killed her husband, okay?
Carol
Fed him to
Baskin
tigers.
killed her
He fed
husband.
him to tigers. They snacking. What's happening?
Oh,
Carol Baskin.
you guys too now?
I don't know what you're talking about.
I don't know what you're talking about. It's like when I like when she pulled an OJ.
that was the highlight of this season, you know, when she pulled an OJ.
She was like,
And OJ responded.
I think
even he thinks that she killed him. Like, it
My
takes
favorite-
one to know one.
my favorite response was thanks for your expert opinion, OJ.
That's funny. I mean, where's the lie?
I don't know. Like, I don't know. How would I even kill my husband? I don't know. Like, cut him up and cover him in sardine oil and then feed him to the tigers. I don't like that'd be impossible. Like, what? No one said anything about sardine oil.
What? That's funny.
Tag based. Control compact. Ethernet. Tag based.
So what's running through your mind, Zach?
I'm trying to figure out what I did wrong. I did
Oh.
something wrong. Ethernet IP client.
Well, it would make sense to have the start and the stop button hooked up to the same bit because of the.
Yeah, you could do it either way, but I don't want to just assign them to a B3 because then we have to go back into our program and assign B3s to all of our inputs and outputs. You know, if I can tie that directly to the button,
It'd make it a lot easier.
yeah, I'm
That's
just unsure
fair.
how to. Let's see how do we do that. I just want to get it working where I can make a new project. One button. All I want to do. I want to try it out. See if it works. So in our logic, what does the green push button do?
Does it
Turns
enable?
on the
Enable
Okay.
P31.
yeah. Which would be the soldering iron.
See if we can do it that way. So this is like towards Nathan's suggestion. Instead of tying it to the physical button, I'm going to try to apply it to the program. I don't want to do that. I'll try it. Why not?
Well, because can you tie a digital input to a mechanical input?
Well, that's not what I'm saying. I'm saying you want to use the HMI to output a true value into the program or in the same place that physical button is. Does that make
Oh,
sense?
okay. Yeah, okay. I got you. Because the way I was feeling, this thing worked is like it acted as a new input, not a substitute.
What I'm wondering is if we don't have to go and add these to the program. You know what I mean?
Mhm.
Maybe that was my mistake. So paralleled around all the inputs that are in the let me show you what I mean. I think what we have to do, and this might, it's been so long since I've done this. All of our inputs we need to parallel like have an HMI selector left, right? And have that be its own input.
So gross.
I'm gonna try it that way real quick, and then we'll end class and go from. I got to figure out what I'm doing wrong here, but I think this will work. Where's the green start button? Holy crap!
Round 2 maybe. Green on milk and push button.
So if I had another parallel. B3. Which one's unused? B32. Let's use my B37. And we'll call this. Oops. HMI green. Okay, I'm gonna say this. I think you're right, Nathan. I think this is the way we have to go. If this works, I'm gonna virtually kiss you.
Okay.
Whoa.
My mouse is so gross.
Oh, is that what you said you about?
Yeah, it's just got like little, so it got little rivets in the side, and like every time it just has like a buildup of crap in the rivets.
That's gross. Just clean it.
Yeah, that's what I'm doing. I'm shoving a knife in it and scraping them out.
All right, so what I'm gonna do is send this to the HMI to try to test it. And you should see, can you see my screen?
I can.
That's the old project that I had in there, and I'm gonna send this, and all it should have is one little button on there. And if I did it right,
The one little button should turn on a process.
Yeah, it should be parallel to the green push button.
It better be.
You know what, John? I'm sick of your attitude, son. You're fired.
Yeah.
Oh, it's doing something.
I tell you
It's
what,
doing
maybe
something.
when you run the class, you can.
It's doing something.
Woo!
Transfer 10.1 seconds. Look, I got one little push button up there.
Yay!
Get it?
Except for Logix, I need to download it. With that
Son,
new input.
I do run this class. This class is mine. Now get out, son.
All right, here we go. Selector left. Now, if I hit that green button on the HMI, it should become true and start the temp control process.
Oh, it beeps when you press it?
Yeah.
Sally's not doing anything though.
PLC 01 communication timeout.
So will we see our sensors, the temperature rise on them?
Oh, okay. So I have to change the IP settings in HMI so it matches the PLC because it's not communicating with the PLC. So we're going to stop there for today. You guys can stick around and watch me try to fix this if you want. Otherwise, we'll pick back up on Friday.
Wednesday. Oh yeah, for this Friday.
Okie dokie.
Okay. Okie dokie.
All right.
Bye, guys.
Bear with me.
Bye.
We'll get her.
Oh yeah. Thank you, Zach.
Thanks, John.